Hello, pre-calcers and IB math students. We are now going to start our study of calculus. Welcome to calculus. So we're going to go through this beginning topics of calculus fairly quickly. So we're going to start with an introduction to limits. That's the first topic in calculus, and it's kind of fun to play around with limits. So what we're going to do first is I'm going to show you some examples using graphs with limits and seeing if we can figure out what the limit is, and then we'll move into using our calculator to find limits. So what do I mean when I say limits? And when I write something like this, the limit as x approaches 3 of f of x, what do I really mean? Well, let me draw a function for you here. Here I am at 3, and that y value, we'll say that's 1. So I've got a function here, and when I say the limit as x approaches 3, so we would write this or say this in English, the limit as x approaches 3 of f of x. So what is the limit as x approaches 3 of f of x? What I'm really saying is, what y value do I expect to get if my x values get really close to 3? They don't ever actually have to reach 3, they just have to get really close to 3. So I'm going to use this highlighting tool up here. So I'm going to come on my function and I'm going to look, oh, I'm going to come into 3. I'm going to ride down, I think of this as a roller coaster function. Oh, look, as I ride in there, I'm coming into 3. I'm coming into the x value of 3. Notice that my y values are getting closer and closer to 1. And as I come in from this side, oh, look, as I get closer and closer to 3, my y values are again getting closer and closer to 1. So like right around here, my y value is 1. So what I would write here is the limit as x approaches 3 of f of x in this case is 1. It's the y value I get as my x values get closer and closer to 3. Okay, so now let's try another function. Let me draw another picture for you. Okay, so now let's look at another example, another function. So in this function here, you can see that there is a hole in the graph right here. You can see there's a hole. So that means that this function is not defined when x is 4. But it looks like it's defined everywhere else. So let's think about what is the limit as x approaches 4 of this function. So once again, I'm going to use a couple different colors. So I'm going to look at what happens as I come into 4 from the left and right of 4. So as I ride, I think of the function as roller coaster. I'm riding the roller coaster from the right, and you can see that the y value I'm coming into, the y value is 2. And if I ride the function in from the left, coming in this way, you can see that I'm also coming to a y value of 2. So in this case, the limit as x approaches 4 of this function is 2. Now, we talked earlier about there's a hole in this graph. So is the function actually defined at 4? If I asked you what the y value at 4 is, what would you have to say? You would have to say that it does not exist, because there's a hole in my graph. It is not defined at that point. This function is not defined at 4. And by the way, this is going to come up fairly often, so you are allowed to abbreviate D and E, does not exist. Okay, so now we're going to look at this function. So as you can see with this function, it looks like it has 2 parts or 2 pieces, and in fact it does. You can see that there's a piece on the left from 2 to the negative infinity, from x equals 2 to negative infinity. It looks like it's going up.
And you can see that there's a piece on the right that goes from 2 to positive infinity that goes up as we move to the right. This is in fact called a piecewise function because it's broken up into 2 pieces. So what we want to do is we want to figure out what's the limit as I come into 2 for this function. Well, remember how I talked about how when I look at limits, I think I'm riding the function as a roller coaster? It looks here like I have 2 parts to my roller coaster, so I'm going to have to look at each part separately. So the first thing we're going to do is we're going to look at the limit. So before I can figure out what the limit as x approaches 2 is, I have to look at the limit as x approaches 2 from the left. And the way we indicate that is 2 with a negative sign in the superscript. And that's to indicate I'm coming into 2 from the left. So if I'm coming into 2 from the left, what I'm going to do is I'm going to come in on the roller coaster that's on the left. Coming in, here's my red pen showing me riding down the roller coaster. As I come in, the y value it looks like that I'm coming into is 2. So that one will equal 2. So now what I want to look at then is riding the part of the roller coaster on the right. The limit as I come into 2 to an x value of 2 from the right side of 2. And again, the way we indicate that is with a plus sign in the superscript. And that's to indicate that I'm coming into 2 from the positive side of 2, or from the right side of 2. And so now what I'm going to do is I'm going to ride the rightmost roller coaster in towards x value of 2. Here I am riding the roller coaster down towards x value of 2. And that will take me to a y value of negative 3. So the limit as I come into 2 from the right side of 2 is negative 3. Notice that the function is not defined to be negative 3 when x is 2. It is rather defined to be 2 when x is 2. So if I were to ask you what is f of 2, you would say f of 2 is 2. Why is that? Because there is a filled in circle at x equals 2 up here at 2. However, down here it's an open circle, meaning it's not included. But for the limit purposes, we don't actually have to get to 2, we just have to get really, really close to 2. So that's why as I get really, really close to 2 from the right side, it's equal, the y value looks like it's getting closer and closer to negative 3. So now let's talk about what does this mean? What is the limit then as x approaches 2? When I'm running these roller coasters, it looks like I'm never going to meet. As I come in on the right, from the right of 2, I'm going to negative 3. As I come in from the left of 2, I'm going to 2. So the limit as x approaches 2 then does not exist. And then we can abbreviate that by writing DNE. And the reason why it does not exist is because the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x. So that is why the limit does not exist. So whenever it says does not exist, you have to justify why.
I've got this worksheet here that we're going to work our way through. We're going to start with the first one here, which is the limit as h approaches 0, 1 plus h squared minus 1 over h. So the first thing you should be thinking about is, oh, I have a problem. I'm going to have 0 in the denominator. So now you're already wondering, is it even possible to do this? So what we're going to do is we're going to graph it and see what happens. Right now I'm predicting like, oh, I have a 0 in the denominator, I have a number in the numerator, because if I substitute in 0 for h, I'm going to get, oh, actually I'm going to get 0 over 0 and 0 in the numerator. So this is what we call an indeterminate form. And so what we're going to do is we're just going to graph these and see what's going on. So we're going to go to the graphing calculator.
Okay, so now we're going to try finding the limit of our function on the calculator. Now on the worksheet, it's used the letter h. Our calculator is not going to recognize that, so we're going to use the letter x in place of h. So first thing you're going to do is you are going to insert a graph page. Add graphs. And now we're going to enter our function. So the function we were specifically looking at was 1 plus x, and we're going to square that whole quantity. So make sure you're outside the parentheses when you choose the x squared. And then we had a minus 1. And then we wanted to divide that by x. What's the problem right now? Right now what the problem is it looks like, because our calculator is going to follow order of operations, that it's going to do 1 plus x squared and then subtract from it 1 over x. So we need to add some more parentheses around the whole numerator. And now our function is ready to graph. So just hit enter and it will graph. So look what happens. As x approaches 0, when we were first looking at it, we knew that the 0 was not in our domain because we would be having a 0 in the numerator and a 0 in the denominator, which is indeterminate. And so we were thinking something funky was going to happen at 0. But if you look at our graph, it looks like a straight line. It looks like nothing funky is happening at 0. So let's look at the table of values and see if that shows us any more insight. So the way we're going to get to tables is you're going to hit Control and T for table. And then you should see over here what pops up is a table of values. X values are in the leftmost column, and Y values are in the column to the right of that. So let's look and see what's happening at 0. Oh, something weird is happening at 0. It says that it's undefined. But our graph doesn't show that it's undefined. So this might be one of those cases where we have a circle or a hole in our graph at 0. In other words, the function is not defined at 0, but it looks like if I were to find the limit, do you remember from the example I showed you earlier, as I come in to 0 from the right of 0, and as I come into 0 from the left of 0, it looks like my fingers would meet at a value. So let's see if we can use the table to help us figure out what that value is. So what I'm going to do now is I'm going to look right around 0. So it looks like when I'm 1 to the left of 0, when I'm at negative 1, my y value is 1. When I'm 1 to the right of 0, my y value is 3. That doesn't look like it's the same number. So maybe we're just not close enough to 0 yet. Maybe negative 1 and 1 are too far away. So the way we're going to get closer to 0 is we're going to go to Menu, Table, Edit Table Settings, and let's start at a number just slightly to the left or negative side of 0. So let's put in negative point, I have to choose this negative right here, negative 0.005. That's pretty close to 0. And then let's approach 0 using really small steps. So we're going to change our table step to be, let's just add one more 0. Instead of 2 zeros, we'll do 3 zeros, and we'll just, again, maybe we'll go by 1. So we're going to approach 0 by really, really small steps. 1/10,000th of a value for each x step. And we say OK. And now we're going to scroll down our table, and you can see we're pretty close to 0. Our numbers are getting closer and closer to 0. And as our x values are getting closer and closer to 0, right now they're still negative, but they're getting closer and closer to 0, it looks like my y values are getting closer and closer to the number 2, 1.99. So let's look on the other side of 0, on the right side of 0. Oh, on the right side of 0, my numbers are also getting my y values are also getting really close to 2, 2.0001. I would say that that's essentially 2, and I would say that 1.9999 is essentially 2 for this purpose. So that says that as our x values are getting closer and closer to 0, even though our function is not defined at 0, our y values should be getting closer and closer to the number 2. And that's what the graph shows us. Now, how come this graph doesn't show us the whole? It's because our calculator is not as smart as we are. And also, it doesn't have the pixels to show the whole. So this is where you have to use your knowledge of math to outsmart the calculator. So this is what you're going to do for all the other limits on that worksheet. You're just going to look and see what happens as you get closer and closer to the value that we're supposed to be approaching. And good luck with that, and bring it in tomorrow and we'll go over it.